Now, we're going to look at transformation of specifically the quadratic function. So let me pick out a pen here. Okay. Does this look like the quadratic function? Well, we know the parent, the very simplest version of this would look like function f of x, or how else do we say it, y, equals x squared. That would be the parent function, the very simplest one we could find. So there's some things that have happened here. Yes, this is function f of x, or otherwise known to us as y. But the thing that's being squared isn't just x, it's x and its horizontal translation. Yes, that's what we talked about earlier. So that's being squared. And what else is happening? We've got this plus k. That's the vertical movement of this graph. So we've got this inside the operation of squaring, and outside that, to move it horizontally, k. The only thing that we haven't talked about, this was actually in section 3, which I skipped over, is the multiplier on this. This will change the shape of the graph. If a is 1, as it is over here, you get the parent graph. If a is greater than 1, it gets really steep. And so that's if a is greater than 1. And if a is less than 1, you get a bowl shape, a very shallow version of the quadratic function. Our objectives today: graph a parabola by converting its equation to display the coordinates of the vertex. Very clever, really. So now we know the vertex because we can see what h and k are. So in a quadratic function, if you convert it into this vertex form, you can look at it and know what h is and what k is for your vertex. And the second objective here, identify the key characteristics of a parabola without having to graph it. Well, one of the things we know is that the vertex is going to show up, if we were doing a table of values, would show up right in the center with some x values less than that and some x values greater than h. And if we were looking at it graphically, here's h and k. In this case, assuming that I've got a 1-by-1 grid here, what is h? With the parent graph, h would be 0 right here. But this has been shifted 1, 2, 3, 4 to the left. So what is my h? -4. So h equals -4. What is my k? K equals 0. It hasn't shifted up or down. What is my a? Well, to know that, I'd say if I go over 1 and up 1, where am I? It's a little hard to tell, actually. Well, I'm going to assume, let's, sometimes, I guess I didn't draw this for this purpose, but it does that. Okay, so let's assume it's right there and it's right there, which of course it isn't, but if I had a graph that went like this, I'm going to reinvent this thing so it does. Oh, it's so bad. But anyway, if I go over 1 from my vertex and I find that I'm going up 1, then I know that my A is equal to 1. Then I could fill in the rest of this, say f of x equals 1, which I'm not even going to bother to write, x minus a negative 4. And that's my operation. Quadratic always is a squaring operation. Plus k. And what is my k? 0. So with a quadratic which had its vertex at negative 4, 0, and this point here at negative 3, 1, I would be able to determine the equation. Okay. The graph of f of x equals some multiplier times a squaring operation, which has my input, and then it's shifted horizontally, and then perhaps we have a shift vertically. We know that h and k represent wherever my vertex is. And what else do we know? Let's see. We actually know so much about a quadratic. We know that the line of symmetry is going to pass right through the vertex. I'm going to put that over to the side. We'll use it on this one. So let's play around with this. This is something that I skipped by. This is when we have a multiplier here, what happens? Well, my vertex, I know what my h is, right? H equals a positive 1. K equals 0. There is nothing shifting me up or down. So I'm going to put this in. 1, 0. Now I'm going to go minus 1 to put this at 0, and then I'll go back 1. And here we'll have 2 and 3. And we'll see what happens. When I put a 0 in here, then I'm squaring a negative 1. Negative 1 times negative 1, positive 1 times 2. So this would be a 2. If I put a negative 1 in for x, I get negative 1 and subtract another 1. So that would be negative 2. Square negative 2 I get a positive 4 times 2, 8. So this is not the shape. This is not the shape of my parent graph. So my parent graph, when I go back 1, I end up, oh, this is a 2 by 2 grid. Okay. So back 1 takes me here, up 1. And on this one, when I went back 1, I was up 2. See how this is going to be much steeper? Okay, let's try putting a 2 in. A 2 minus 1 gives me a positive 1. Squared is still a positive 1 times 2. So 1 times 2 is 2. Put in a 3. 3 subtract 1 gives me a 2. I square 2. 4 times 2, 8. So you can see the symmetry here. My vertex is at 1, 0. So put it right here. And what else do I have? If I have x equals 0, if I have x equals 0, I go up 2. If I have x equals negative 1, I go up 8. If I have x equals 2, I go up 2. If I have x equals 3, I go up 8. So we can see the symmetry here. And I could draw this right now. Boy, that is terrible looking, isn't it? Wow. Okay, let me try drawing what the parent graph. The parent graph would have been with a vertex right here. But suppose I move the vertex over here. With the parent graph, when I go over 1, I go up 1. So even just shifting horizontally 1, I can see what the shape would have been. And I go over 2, I go up 4. Over 2, up 4. I'm just comparing the shape of this one to the shape of what the parent would have been. Over, let's see, 1, 2, 3 would have been up to 9. So I'm putting it in the same place, and then this would be right here. But you can see that this parent would have been a little wider. So when we had an A equal to 2, it made the graph become a little steeper. Made these points rise much more quickly. The line of symmetry, let's put that on there. It goes right through the vertex. So there's my line of symmetry. Find the line of symmetry and the vertex. Find the minimum or maximum value. Now I can do this by graphing this thing. I know where my vertex is, don't I? My vertex is h equals a positive 1. Notice that. because it's minus whatever the horizontal shift is. And my k, in this case, we're adding whatever it is, so that's also a positive. K is 3. So I can go ahead and put my vertex in right down here. 1 and 3. Now I could go back. 0, -1, 2, and 3. This looks sort of similar to what we were looking at a moment ago. Let me go back. We had a vertex at 1, 0, and a line of symmetry at x equals 1, and a multiplier on it of 2. Now we're looking at almost the same thing. What is the only difference? Right here. This has been shifted upward. My parent graph would look like this, and my new one is shifted up. It's shifted right one, and it's going to be steeper. There's a lot to think about here. So we have found the vertex. The vertex is at 1, 3. So let me mark that. Over 1, up 3. So here's my vertex. Right about there. At 1, 3. I probably should go ahead and put down the point coordinates. The line of symmetry, I'll pull that line of symmetry over, because I already know, as soon as I know the vertex, I know the line of symmetry. The line of symmetry is going to be at x equals 1, right there. Now, what's going to happen with my y? Let's try it out. If I put a 0 in here, I'll have -1. I square -1. Squaring -1 gives me +1. So I've got 2 times +1, which is 2, plus 3. 2 times +1 plus 3. Whoops. Oh. 2 times +1 plus 3. 5. If I put a -1 in here, I'll have -1, -1, same as -2. If I square a -2, I have a +4 times 2 gives me +8 plus 3. Ooh, we're getting up there, aren't we? Let me just graph those points. When x is 0, y is 5, right here. This is a 2 by 2 grid. By 2 grid. And then when x is -1, which is right here, y is 11. Right up here. Let's try putting in a 2. 2 minus 1 gives me a 1. Squared is still a 1 times 2. 2 plus 3, 5. I knew that anyway, didn't I? Because of my line of symmetry, I know from my vertex, if I'm moving the same amount, I'm going to be going up the same amount. So I've got over 2, up 5. Over 3, up 11. Okay, so here we go. That's where it graphs. I'm going to try something different here. Let's see if I can grab, oops, not that. I'm going to see if I can grab this piece here. Let me group that together and edit, we'll say edit, copy. Now I'm going to go back here and we'll say edit, paste. So this is the one we just did on the following page. And if I were to put it in here with my vertex at 1, I probably should change the color, don't you think? Let's make this one something interesting. Okay. We'll give it an interesting color. We'll make it orange. How's that? Okay, so we're going to put that at x equals 1. There it is, x equals 1. Now I notice that x equals 1 is exactly the same as the graph we did before, but now I'm going to raise it up. There's 2, there's 3. So it's the same as the one we did before. I think it shifted a tiny bit there. Ah, forget that. Anyway, there it is. It's just up 1. Graphs with the vertex form. All quadratics can be put into the vertex form. So if the equation, and this looks like the parent, doesn't it? Y equals x squared is transformed in this way. So it's x minus 2 that's being squared. So it's been in the domain that we've made the change. This is h. So this thing has been shifted. How has it been shifted? Move parent. And I can say that with confidence because, look, there's no multiplier on here. So it's going to have exactly the same shape. Move parent 2 units in which direction? Right. That's how it's transformed. That's the only transformation. We're not shifting it up, and we're not changing its shape. If the parent function is transformed to this, what happens? I'm not even going on to the rest of this question. So now, that's a pretty steep increase, isn't it? This graph is going to be very skinny. Still going to be a quadratic, but it's going to be very skinny. For every 1 that I go over, it's going to go up 3 times as fast as the parent did. And it's then transformed by adding something into the operation, into the domain. This means it's moving 2 units right. How is the graph transformed? It's narrower. By 3, and that's a multiplication of 3, and shifted right to units. Okay, so the vertex form, we could just look at the equation itself when it's in the vertex form and know quite a bit about what the graph looks like. Let's see if we have anything else to look at. Yeah, one more. Without graphing, find the line of symmetry and the vertex. Well, that's pretty easy for us to do, isn't it? Let's start by finding the vertex. My vertex, of course, is H and K. And this works if my equation is in the vertex form. Let's check and see if it is. Notice that in the vertex form, inside the parentheses, x has a coefficient of 1. Any multiplier on x has been pulled outside the operation. So x minus whatever the horizontal shift is, which is going to tell us the x-coordinate of the vertex, and then outside the operation is our k. So in this case, what is our vertex? Our x-coordinate is found right here, and remember it's minus our x-coordinate, so that's a positive 5. And our y-coordinate is found right here, and that's positive. It's adding it, so adding a 3. It's positive 3. Our line of symmetry is always going through the vertex. So our line of symmetry is x equals 5. Because our A is positive, we know that this is a parabola that's opening upward. Had this been negative, it would have been opening downward. So if it's opening upward, are we dealing with a maximum or a minimum here? A minimum. And the minimum is at y equals 3. So you can see once you have the vertex, you also have the line of symmetry and the value of either your minimum or your maximum. This would have been a maximum value had I had a leading coefficient here that was negative. Oh, and down here I do. So we know in this case, my parabola is going to be opening downward. The line of symmetry and the maximum value I can get from the vertex. Let me get the vertex first. The vertex is at, that's right, it's positive 6, positive 7. So my line of symmetry is at x equals 6. And is this going to be minimum or maximum in this case? Yeah, maximum because we've got a negative here. Y equals 7. Okay, that does it for this lesson, which is just 29 minutes long, not too bad. Let me get a star here. We'll just draw some stars to congratulate ourselves on sticking right through to the end. See you in class.